Hello geometers, and welcome to the lesson on parallelograms. In these next few videos we are going to focus on mostly proving the properties of a parallelogram. But first let's review. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So this is the picture that many teachers often draw for their students the first time when they talk about a parallelogram. And I am no exception. I would draw the same picture here. So it's a kind of a slanted rectangle. Both pairs of opposite sides, so these two sides, I should name this A, B, C, D. So A, B, and C, D are parallel to each other. And then B, D, and AC are also parallel to each other. Okay? And that's it for the definition of a parallelogram. Everything else that we know about parallelograms can be derived or proved by studying the various symmetries that we have here. And let me show you what I mean when we talk about these theorems. So it's not so important to memorize the number of the theorem. In fact, that's really meaningless. What we want to focus on here is what it says. If something is a parallelogram, then its opposite sides are congruent. Now here we have opposite sides parallel, and we want to show that the opposite sides are congruent. And the general strategy, for all of these proofs is to create triangles to show the triangles are congruent, and then use CPCTC as our method of proof. And let me show you what I mean. So I'm going to use this same picture here, and I'm going to prove several of these properties actually. So if we go with our strategy here, create a triangle, and I'm going to create it by drawing these transversals, or drawing this transversal in here. Okay. Now you can see that we want to show that these two triangles are congruent. We want to show that. So somewhere in our proof, we have to say triangle. So there's going to be quite a few steps, but triangle ADC is congruent to triangle. ADC. So ADC. So BDA. So we want to try to show that those two triangles there are congruent somehow. And it's not difficult to show once you exploit the fact that you have parallel lines in here and a transversal. So if you look at just extending this line up here and this line down here, you can see that these two angles are alternate interior angles cut by a transversal of parallel lines. So I'll just name this, just for simplicity's sake, angle 1 and angle 2. Okay? So we know that angle 1 is congruent to angle 2 because of the alternate interior angles theorem. Okay. Not only that, if you extend these two lines here, the vertical lines, using the same transversal, we can see that these two angles here must also be congruent. So we'll call that 3 and 4. So angles 3 and 4 are congruent by the alternate interior angles theorem. And then you have a side length in the middle here, AD and DA. So AD is congruent to DA, and that's because it's reflexive. Okay. Thus, these two triangles are in fact congruent by angle, side, angle. So angle, that's 1 and 2, the side, and then 3 and 4. Okay. Now, since the triangles are congruent, we can say lots of things about them. We can say that AB is congruent to CD. by corresponding parts of congruent triangles are congruent. We can also say that AC is congruent to BD for the same reason, and thus these two steps here, oops, I'm writing off the screen, prove theorem 8.3. Well, we need both. Well, we need all of this stuff right here to prove theorem 8.3, but you can see that by getting the two triangles to be congruent, we're able to extract this part from it as well. And not only that, the second part here, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So you can see here that B and C are congruent. So I'm going to extend on this. Angle B is congruent to angle C because of CP, CTC. And angles A and D, or CAB and BDC, you can see this angle up here, the one that's formed by the red lines, is formed by angles 1 and 3, and the side opposite that is formed by angles 2 and 4. So, but 1 and 2 are the same, 3 and 4 are the same, so these two angles up here must also be the same. And you can also prove those two are the same just by drawing a different transversal. So this theorem is also easily proved once we have this these two triangles being congruent. Okay. All right. So that's a brief introduction into parallelograms and their properties. I'm going to end this video here, and I'm going to talk about one more property, which is 8.5 here. If a quadrilateral is a parallelogram, its consecutive angles are supplementary.